Hello all. I'm just gonna take a minute here and get confirmation from my colleague who's in the audience. We're gonna make sure logistically that my audio is getting through and the video is working, which it appears to be. So our logistics are all in order. So I guess we can get started. It's good morning, good afternoon, or good evening, depending on where you're coming from. For myself here, we're out of the US, so good morning. What we are going to be doing, if you are a returning attendee, you've come to some of our previous webinars, you sort of understand how this works, how the Zoom software works for the webinar, and how we'll be running things. However, for those of you who are first timers to our webinars, I'm going to explain a little bit about how we run them and the tools that we utilize. So I'm going to be going through today. We're going to be covering, if I can bring it up here. The following topic, as you can see here. What we'll do is I'm going to present on some information that I've covered quite a few times, actually. I'm going to work my way through the material. We're going to try to keep it within 40 minutes approximately, because it does look like we have a good number of attendees. I expect a robust Q&A session. So I do want to leave ample time to get to all of your questions, which we try to do with each webinar. In regards to the Q&A that we'll have at the end, if you do have a question, you can speculate a bit in the chat, talk to others in there if you would like. However, the questions that we're going to address at the end will be the ones that we field from the actual Q&A tool. So you'll find in Zoom that there's a Q&A you can click on. You can enter your question for me. What I'd really like for you to do here is to utilize the upvote feature. Because of the number of attendees that we have, I expect a lot of questions with this one. You can help us out a lot by upvoting questions that are consistent with a question you would like to ask so that they're not redundant, as well as questions that you think are the most pertinent or the most important. That way we can start from top to bottom. I expect to finish the questions. We always do our best to answer every single question. However, if we are running out at the end, I want to get through the most pertinent material as voted by you, the audience, first. So if you can do that for me, enter all questions you have through the Q&A. That's where we'll answer them from. And be sure to upvote when we get towards the end. You can enter a question in Q&A at any time, and I actually encourage you to do so. Quite often, this is one of the few advantages of a remote webinar of this nature. When you're in person as an audience member, you have to jot questions down by hand so that you remember them. Here, you can simply enter questions as they come to you. That way they'll be there at the end. You don't have to remember them. So that's how we're going to run the Q&A session. As you can see, our topic here, a quick guide to fixing common statistical mistakes. As I previously mentioned, this is a topic I've covered quite a few times. The content that I have here for you has been adjusted several times for several different audiences. Statistics is quite difficult, and I think it can be very daunting to the scientists because we're merely using statistics as a tool, unless our field is statistics itself. And so we're using it as a tool, and it's really something that's science adjacent for us most of the time. Most of you probably have statistical coursework, statistical training. So as you would suspect, I'm not here going to be covering all the statistical methods. I can't condense coursework down to a single webinar. What we've decided to do with this, and what I think has been extremely helpful to audiences in the past, is I take the question of statistics from the perspective of getting your paper published. So rather than worrying too much about teaching you statistical methods, which you would have to learn for yourself for each given experiment you have for the common methods within your field, we can cover what you can do with your statistics as it's reported to increase your chances and give you better publishing success. I think statistics, as it pertains to the manuscript, is one, very misunderstood, and two, it's underutilized in terms of what you can be doing to increase your odds of success. So what we do is walk through the entire manuscript and find out where the problem areas are. We will cover some common statistical tests in brief, but again, if we just covered statistical methods, perhaps only 10% of the content would be interesting to you because you're not using the majority of methods because they're field specific. So to get into it, just a little of my background to start. I'm Dr. Clark Holdsworth. I'm the Research Communications Manager for LetPub. Previously, I'd earned my doctorate in physiology from Kansas State University, which is here in the US. At that time, I was focusing on the O2 cascade from ambient air all the way down to the capillary level and into the very small partial pressure gradients of oxygen to the muscle myoglobin. During my time there, I also worked with several animal models of disease, most notably chronic congestive heart failure. What's really important here, though, is in my time since then, since being a practicing scientist, I've seen thousands of manuscripts across all fields. And so I'm able to look at statistical issues from a more global perspective within the scientific community. My concerns don't need to be specific to any one field. I'm focusing on things that we see in those thousands of papers that we process every year. In particular, we see a lot of peer review. So I have access to reviewer comments across fields. And so I've seen every single concern that you possibly could from a statistical point of view from the reviewers or from the journal editor. So to get into it, I actually threw this in. This hasn't been in my previous content that I've covered. What you'll see here is this is really an overview of how the talk works. And what you'll notice is it's essentially the same overview as the sections of your manuscript. And that's how we end up tackling it. So quite often, I think a major issue is that people think of statistical analysis as it relates to their manuscript only as the section, the subsection of the methods that's labeled statistical analysis. It's quite a bit more than that. And I'm going to have a little bit more detailed point by point in the next couple of slides where I go through each talking point we're going to have for these sections. But this is really what we're following. We're looking at the introduction, where are elements of statistics here, and where is a statistics-minded reviewer going to be concerned? And we'll do that for each section because each section does have these issues of concern as it relates to statistical analysis, not just that subsection within your methods. At the end, we'll kind of revisit. We'll be thinking about peer review the entire way through because I'm going to tell you what reviewers are thinking about, particularly those that are inclined to statistics. But at the very end, we'll sort of revisit peer review and things to keep in mind as you work through your manuscript and get it ready for submission. So as I mentioned, the goal here is we take a manuscript-centered evaluation of the statistical analysis component. So focusing on the elements that will help you get published from a statistics perspective. In that regard, we're delineating this relationship between what's the conventional scientific communication and then the statistical methods that you are actually utilizing to process your data. So the concern is, are we adhering to norms? Generally, the entire idea of scientific reporting is attempting to adhere to a norm. The closer you adhere, the better your chances of getting published. You're decreasing the risk of rejection for something unrelated to your science. I think people overlook the statistical component, so that's what we can address here. So the concern then is this interface between conducting and reporting of your analyses. Your ability to conduct the analyses is simply going to be through what you've established as a best practice for statistical analysis in your lab. However, I think what happens is not that there's an initial problem with your statistical analysis, it's that you misreport or underreport in particular, we'll get to that, what you're actually doing. And so the reviewer becomes jaded and distrustful of you based on your inability to properly communicate what you've done with your statistical analysis and make it clear. What happens then is you're getting rejected for things you can't address. They have a bad perception of your paper because something seems off and they don't think they can trust your statistics, because remember, statistics is a completely non-transparent sort of element. You say you run the statistics and these are the results you got, but generally not all of your raw data is available for somebody to replicate that. So they're essentially trusting you to a degree. If you don't seem like you're adhering to norms, there's going to be distrust and they'll find a reason to reject your manuscript. So this is the way we want to think about it in order to improve our publication chances. So the issue here is that this relationship between your scientific communication or reporting and the peer review process has been changing. There is quite a bit more rigor towards the statistical analysis of our data now. You have more statistics-minded reviewers. And so the problem you run into is people aren't conforming to these norms, and they're running into trouble more nowadays than they used to. And again, this problem is if someone has an issue with your statistics, if they don't trust you, it's not going to come out in that way in the review. They're simply going to find some other way to reject you. They're going to just make a broader claim about novelty impact, and it's really going to be based on this idea that they don't think the data coming out, the analysis of that data, is up to snuff. So that's essentially why do we talk about statistics. And these are two important items I think you need to keep in mind. Again, despite this appearance of a subsection of the methods being labeled statistical analysis, it's pervasive throughout your manuscript. And each part has to be done correctly and adequately. Otherwise, you're going to have huge problems with the reviewers. And a lot of times it's simply for no reason. You just didn't approach it. You weren't aware of it enough in the preparation of the manuscript. The statistical analysis is the crux of your experimental approach as well. Your statistical analysis is what allows you to leverage your study design. So the type of data and the level of evidence you're able to establish is then utilized by your statistical analysis and strengthens your conclusions. Because again, testing hypotheses is simply an approach for reducing bias. It's a decision-making tool that scientists borrowed from the field of statistics so they could provide an objective assessment of the data, so that across the community, we could agree on certain norms for how statistics can be used as a tool, what thresholds we need to meet to make certain statements to arrive at certain conclusions. And that's what the reviewer is concerned with. Are you arriving at conclusions that are valid given your level of evidence and the analysis that you've performed? So these are really the main points of the paper that you want to focus on. So if you're going back through a manuscript after this webinar with us, this is what you should be visiting, and this is sort of what you should be highlighting. If you've been having trouble with statistics-related criticisms during your journal submissions, what you should be doing is focusing on this list and addressing these concerns for the next manuscript you prepare. So obviously, to start off with, within that introduction, the hypothesis is the statistical component of that section. Your ability to state a testable hypothesis is huge. A lot of times a reviewer is skipping down to that early on to look at it. It's a statement among all the other sentences in your introduction that's going to stand out the most. When someone states their purpose, their aim, or their hypothesis, this is what's getting keyed on. If you haven't done this properly, basically an entire 2 pages, which would comprise your introduction, aren't effective. The reviewer gets to the end there, looks at your hypothesis statement, and already has concerns. So we're going to highlight a couple things about that should help you out. Next on the list, you then have study design. When you move into your methods section, forget about the statistical analysis subsection. When you start outlining your study design, this is laying the foundation for all the statistical concerns that the reviewer is going to have thereafter, because they're going to match your statistical design to your study design, because they're obviously coupled. What you can do with your statistics, what's permitted by the community, will be dependent upon the design of your study. So make sure that you're outlining everything. Again, we'll move into that and I'll give you details on things you should be looking out for. The big problem tends to be underreporting or reporting that's unclear. Obviously, then you have the statistical analysis section within the methods. The concern here tends to be underreporting. We'll get into that, cover some details, but this section ends up being very small, only a couple sentences. It's one of the few areas in the manuscript that could be expanded without concern from the journal editor, reviewers, anyone. No one's going to be concerned if you double the sizes of your statistical analysis section, which really could not be said about anything else in the manuscript, because there's already concern about how long manuscripts can get. Then moving on, obviously your entire results section ties back to your statistical analysis, because there's usually an element within every single statement in your results. You have an element there borrowing from your statistical analysis. You then move on to your tables and figures, again, part of the results selection section collectively. Those tables and figures, there's independent concerns from the text with those tables and figures, and you represent your statistical analysis in those items differently than you would within the manuscript itself. And then finally, moving on to the conclusions, statistical analysis can be present throughout the discussion, but the big item is the conclusions. The reviewer is going to get to the conclusions and make a decision on the veracity of your claims based on how it aligns to your statistical analysis and your study design. So you can see that statistics is pervasive throughout. There's components within each section that are going to pop up in a reviewer's head. They go, this is the stats check throughout in each of these sections. All of these have to align with each other. If they don't, that's what raises concern with the reviewer, and it's going to lead to rejection. So you can see what I've done is titled the slides. So we have each section that it falls with underneath. So we're obviously going to start with introduction. As I mentioned, hypotheses are your primary concern here. I've always liked this quote. Hypotheses are nets, only he or she who casts will catch. Since this is from antiquity, it's probably misattributed, but I've always liked it as a statement for scientists. The big thing I see is people that are not stating hypotheses, which is a huge problem. Obviously, not all science is hypothesis driven. So you will have instances where you don't necessarily have an explicit testable hypothesis, but that's not what I'm seeing with the papers that we get. We just see people either omitting a hypothesis or presenting a hypothesis more as an overall aim of interest rather than a statistical statement, which is what a hypothesis is. I have some reminder material for you here that you should have had in any of your basic statistics classes. But the concern with the hypothesis is that it's testable and that it's specific. So keep in mind that any inferential statistic is always going to be telling you information based on this assumption that your null hypothesis, your H naught, is true. So it's going to assume that there is typically what your null is a hypothesis, no effect or no detectable difference. So statistics are always going to tell you something based on the idea that that is the default, that that's true. And the way that we end up interpreting statistics, I think, has skewed away from that. So we can cover how to keep that in mind and not get flagged by a review. As I mentioned, hypotheses need to be specific. They also need to be falsifiable. Poppers, there's obviously a lot of variation in how we utilize, or in the philosophy of how we utilize inferential statistics. However, I think most of current practice and experimental work is based on Popper. This idea that your hypothesis needs to be falsifiable. So when you state a hypothesis, I'm looking for whether that can be tested, and therefore your language here needs to be very, very specific. So something as simple as substituting words like increase, decrease for something like improve. I think you can generally get away with a term like improve, but I'd rather focus on the variables. If you put the variables first, it makes your hypothesis more specific and therefore falsifiable. When you get to the results section, that reviewer or that reader can then look at your results and say, okay, what happened with this variable based on their analysis? That will then mirror what you had for your hypothesis within your introduction section. It should be one-to-one. It should be as simple as possible for the reader. The testable hypothesis that you have, the language should exactly mirror whatever findings are going to be reported in your results. So I think this is a good general rule to simplify your hypotheses. Don't frame them as larger conceptual questions. So typically what you're doing with a hypothesis is looking at a difference between some sort of indicator of central tendency. The most common one is the mean, although the measure of central tendency that we select is often based on the distribution of the data. Again, this design, your design should be evident in your hypothesis. While your overall experiment might become quite complex, whatever you state for your primary hypothesis should give away the nature of your study design. So repeated measures between groups, among multiple groups, regression analysis. I should be able to predict based on your hypothesis what your study design is going to be. So this is a great test. You can, as a general rule, what I would suggest is when you're trying to test whether these things are clear, give your paper to someone, a science literate friend who's outside your field. Don't review it yourself. Don't have your colleagues review it. I think if you go to someone independent, they can ask themselves these questions, perform these checks for you in a more objective way. But that design should be evident within your hypothesis. The hypothesis can sometimes be dependent on a subjective threshold. So for example, when we're looking at model fits, so how accurate is this model that I've created compared to another model, or how much variance is accounted for by a regression analysis. These things are a bit subjective, but each field tends to produce norms for what they view as, for example, a strong model fit or a strong relationship between variables. So make sure that you verify those first, and those thresholds should be established a priori. So don't, in the results, tell me that an effect was strong without setting that up beforehand. If you use the wrong word strong, weak, moderate, good, adequate, if you're using any of these words in the result for a subjective threshold, that threshold should already have been established. It's just like failing to define a term. If you fail to define a term like strong, weak, moderate, it's going to cause problems for you when they get to the results, because then they can simply argue with you. And you can set it how you want, but I would, again, suggest looking at the literature, leveraging it, and establishing it a priori. And of course, if you are using the literature, make sure you cite here. Oh, I actually do want to go back. What's important to keep in mind, this is getting into the more basic statistical concepts, but as I mentioned before, your hypothesis testing is always based on this idea that the null is true. It's telling you something about your data under the condition that the null hypothesis is true. So you need to keep that in mind when you make any of your statements. What people end up doing is they have an idea that the p-value is telling them something about their experimental or about their the likelihood of their experimental hypothesis, which is not necessarily true. So just keep that in mind as we work through the rest of this. So moving on into the methods for your study design. So information that's pertinent to statistical analysis is going to be present in here. The most important things are your sample sizes. So you need to make sure that your n's are clear for your groups. So each group, you should have the number of groups, the conditions, the time points, what other variables go into your experimental design, and make sure that a sample size is associated with each group. A big problem that I see in study design is quite often, if it's not explicitly stated in the correct order, your reader will often get confused about, for example, what's part of the study design and what's part of the subgroup analysis. So oftentimes subgroups get confusing when you don't lay out your study design very well and very clearly. Your reviewer can get very confused when you also have subgroup analysis, because this isn't actually a methodological grouping, it's a statistical analysis grouping. And so make sure up front that your study design is clear, so that if you do have something like subgroup analysis, when you move into it, the reviewer is not getting confused that these are actually different methodological groups. With that in mind, I always encourage schematics. Sometimes you don't have room for a schematic. You may have a huge number of figures, tables, this type of thing. So that's understandable, but I know a lot of you don't. A lot of you will have a reasonable number of figures and tables, and you certainly could include a schematic. So always feel free to do so. Quite often we'll see people put schematics into posters that then don't make their way into the manuscript. And I think it's extremely helpful. So remember, a schematic doesn't have to be huge. So it can take up very little space. It doesn't even have to be up here within the text once it's produced by the journal in a large size. It's not some huge table. You can produce a small schematic to guide the reader through your study design. Particularly if you have a complicated study design, I think this is something that you should consider. Again, here, as a reminder you'll see high specificity is necessary for these descriptions. The circumstances that you're going to end up outlining here are going to affect the conclusions that you are or are not allowed to infer from the results. And a good reviewer, a statistically minded reviewer, is going to pick up on this. As they look through your study design, they're going to make the decisions right then and there of what they expect to see in your conclusions. If they then get to your conclusions and it doesn't align, it's going to be a huge problem for you. And again, this is simply because of sloppiness, because we don't think of statistics as being this linear component throughout the manuscript. We don't mirror these sections to one another. But you have to remember that that's what a lot of times what the reviewer is doing in their head. So when you're doing the study design, always compare it to your conclusions and say, is this what the reader should expect? If not, revisit your study design and see how you can clarify things further to make sure that that continuity exists. So in the methods, some of these are just general best practices for science, but when I'm putting them here, I'm actually mostly concerned with how they reflect on you as an author and thus how the reviewer views you. So rigorous reporting of the study design ensures that reproducibility is possible, which again, for a statistically minded reviewer is a major concern. So you want to make yourself look good. You want to align with this norm of reporting in a reproducible manner. Also, briefly report previous methods. Don't merely cite. I see a lot of citations of as performed previously. There's really no reason to do that type of thing. Obviously, you don't need a page for any given method, and you do want to cite, but always do this type of in brief and describe a sort of overview of the method. You may not need every single detail, and that you can utilize that citation to cover what you don't cover. But too often I'm seeing people who don't put content in there, and there's really no reason, because journals aren't concerned with how long your method section is. And in fact, journals used to sometimes have guidelines by section. You basically don't see that type of thing anymore. Journals no longer have length restrictions for your methods. They also now not only allow, but actually encourage supplementary materials. And so stuff like this can go into that, but make it available. Don't hang your hat on a citation too much. I see too much of it, and I think what's happening is that many reviewers are seeing that, and it's leaving a bad taste in their mouth. So if they can't quite figure out your methods, they don't really know how to interpret your results, and they don't really know how to interpret those conclusions, again, in that manner of aligning the three. And if they have doubt, they'll just say, forget it. They'll just evaluate your paper poorly. And again, this tends to be an issue that you can't address. So just make sure that you're paying attention to this, and don't be scared about increasing your methods length in order to necessarily describe your methods or your study design. So the last item I have here, if you do have discrepancies in study design during replication studies, it can lead the community to believe, in a best case scenario, that you simply did something wrong, that you were incompetent in your statistical analysis, which is going to reflect poorly on you, obviously. But I think what happens more often, because we tend not to be very forgiving of one another, in a worst case scenario, the community is going to think that you intentionally altered your results. So it's not just a concern of getting published. This is one of these career risks that you need to mitigate. You could accidentally find yourself in a bad situation by having any discrepancies in your study design, underreporting any aspects of your study design. If someone then goes to replicate your data, they're gonna look at that and think this person intentionally came up with statistics that they shouldn't have arrived at. So you want to avoid that. Okay. One last note I would like to make here. Again, in terms of conforming to norms, giving a statistics-minded reviewer or journal editor some encouragement that you have approached this rigorously. There's a lot of new trends, particularly pre-registration of your study design, which can be conducted at places like the Center for Open Science. Being able to be upfront and transparent about your study design, your a priori hypothesis, these type of elements, it's something that you can take advantage of. Any journal editor or reviewer that sees this, perhaps if they don't see it, it's not a problem like the other things I'm going through. It's not something they notice has been omitted, but it is a thing that can actually help. If you are going above and beyond in this regard and taking advantage of these pre-registration options, this can get, again, this idea of adhering to norms, this can encourage the reviewer that you're on the opposite end of the spectrum, that they can put trust in the statistics that you're reporting to them. So it's just an aside. It's not something that's necessary. Again, I don't think it's an error of omission. However, I think it's something that could be to your benefit and really requires very little effort on your part. So moving into the statistical analysis section of the methods, this is what people think of as the stats for the manuscript. Lack of transparency here is problematic. Again, best case scenario, they think that you're not careful with the selection and rigor of your sample. So they look at your statistical analysis statements and you're missing components. You haven't reported thresholds. You haven't reported your descriptive statistics in full, your approach to everything. If you have errors of omission here, it's going to be severely problematic. They're going to assume either that you aren't careful or that you're intentionally making this section minimal because you don't really know what you're doing with it. And this can be hugely problematic. Again, because they're not going to say this in a review to you. They're simply going to find a way to reject your paper, and you're not going to be able to deal with this in your response to reviewers. So always establish your level of significance for experimental work where you're conducting hypothesis testing. And then again, make sure you're consistent. So make sure that's mirrored throughout your results. Again, always report the statistical software used. This is something huge. You'll notice I have the little red pound symbol right here. I've marked a couple things throughout with this that comes up a lot. This is a big thing. Report your statistical software. Statistics nowadays are a bit black box. So you are not reporting the equations that you use. You're reporting statistical software that processes the information for you. What ends up happening is that's done a little bit differently with every piece of statistical software and with every version. So make sure you're reporting the software and the version, because this comes back to replicability. So that way, if someone runs your stats, because they do have the data necessary to do so, which is becoming more common in this era of open data, if they run it and there's a slight difference from yours, you have a way to defend yourself based on this idea that using different software can result in some small discrepancies. So always report that software. Okay, we will get into a couple just because I want to highlight them. Students' t-test is super common, so quite often you're going to be running a t-test. Make sure it's reported. Report the t-test and report whether it's paired or unpaired. Again, this is going to impact the strength of the conclusions that you make. It's also going to impact what the reviewer expects you to do with the rest of your statistical analysis, because paired is going to have greater power due to the experimental design. The students' t-tests are good because they're robust against violations of equivariance and normality. That doesn't necessarily mean you shouldn't report it. What I end up seeing a lot of times is people don't report whether the data violates or doesn't violate tests of variance and normality. The problem is most of the time those tests come back and they are passed, essentially. Even when they're not passed, it's usually okay, because these type of tests are robust. As long as the sample size is large enough, they're robust against these sorts of violations of those tests. So if you run it, it comes back and warns you that it doesn't adhere to the normality, but it's usually not an issue. However, you should still report it. So make sure that it gets reported. Make sure that the reviewer understands that you're looking at it. Again, these are errors of omission that can cost you. So this is just one example of the simplest test that I'm sure many of you have within your manuscripts. This is a sample of going through, reporting everything, not making any omissions. Same thing, what we have here is for regression. The most common regression analysis is obviously the simple Pearson product correlation. Always exercise caution when interpreting the statistic. We can talk about it a little bit more when I go over the results. But people want to leave explicit statements of causation here, which is obviously flawed. Any basic stats course, you've learned that this is not automatically causation. You're establishing a relationship here. Your ability to experimentally manipulate the independent variable helps with your case of causation, but be careful about wording it that way. Emphasize the relationship between variables, and always report exactly what your analyses are. So if you're doing something one-way ANOVA, two-way ANOVA, mixed ANOVA, any of these items, make sure they're explicitly reported. Make sure you're reporting what groups these are being conducted on, what time points they're crossing, so that the reviewer can, again, align this statistical analysis with your study design. They should be able to glance between the two, and they're mirrored. It makes sense to anyone. Also, keep in mind, if you do have regression analysis where you have variable selection, make sure you report how it's done. So any element within the process of running that analysis, make sure it's reported. Don't make any errors of omission here. Okay, correcting for multiple comparisons. You have Bonferroni, Sidak, Tukey. I'm not going to go through all of these here. I just like to throw them up as an example of what reviewers are thinking about when you come across an item like this. Correcting for multiple comparisons is quite common again. These are the types of things reviewers are going to be thinking about. How appropriate is the test? Typically, they don't even care. They just want to see that you report it so they know that you thought about it, right? So they don't really care if you choose a Bonferroni over a Sidak, over a Tukey. It's very rare that they're going to come back to you and have a problem with that. But if you don't do it, again, it's this thing that sort of casts doubt with the reviewer and they find a way to reject your manuscript. So make sure you're reporting. It demonstrates rigor, even though you think it's not important. a reviewer is getting a perception of your statistical acuity by looking at these reports that you're giving. And moving on to the results section. So again, this is where your reviewer is going to be, they get to the results, they start to see statements that relate to statistical analysis. Their mind is going to go back to your hypothesis, which they keyed on, it sort of came up as a red flag at the beginning. And their mind is going to go back to your methods. They're going to think about your statistical analysis subsection, and they're going to think about your overall study design, and they're going to be testing you. As they read through your results, it's going to be a test. Does this align with what I've seen previously here? And so a key aspect here, these are some best practices. Avoid redundancy. Results reported in the text should be reported in the text or in a table or figure, not both. Instances of overlap are going to be revised, and consistent overlap could be used to triage. What happens with overlap is it makes everything very messy. Again, particularly if you have something more complicated like subgroup analyses, when you have overlap, it starts to cloud the reviewer's understanding of what your study design actually is. So make sure that you reduce that overlap, make sure it's clear, put your primary concerns up front. So your hypothesis is generally not comprehensive of your overall data analysis. It's usually focused on primary variables. So address the results pertinent to your hypothesis clearly and early on within your results section. Another item here, do not re-summarize the methods, which I think is a huge problem. This happens a lot of times where you start to go back into methods. Again, it confuses things. The reviewer is trying to look at this parallel flow of the statistical analysis component of your science throughout all these sections. If you start mixing sections into each other, it just muddies the understanding they're trying to get. And again, once their understanding gets confused or clouded on these type of issues, statistical issues related to science, they just start to not trust you. And that's not something they're going to work through. They're just going to look for an excuse to reject your manuscript. Okay, so here's a couple very nitty-gritty details for your results section and very common mistakes that we see. A result is typically termed statistically significant, or it's simply called significant if a p-value is below a certain threshold. The most common threshold to be used is 0.05, 0.01. Keep in mind that this designation is a construct of scientists, not statisticians. Statisticians didn't decide that this threshold means a hypothesis should be accepted, or this threshold determines that it should be rejected. Scientists came together and made a decision as a community to figure out what's our norms. How do we want to use this tool? The statisticians simply provided the tool as a potential inferential tool. Scientists decided that it was acceptable to use it, and they decided what was the acceptable risk of those type 1 and type 2 errors that you saw on an earlier slide. Once you've established your level of significance, do not violate it. So once you've established significance, which you typically do in your statistical analysis section, do not let a reviewer anywhere find you stating something like X was greater than Y, but the result didn't reach statistical significance, or X was marginally significantly different from Y. These statements make no sense when you've already told the reviewer what your thresholds are. You got to decide. You decided for your paper, for your study, what the threshold was. There's no reason that you should be contradicting yourself. You're better off going back and making up a new threshold that people might have a concern with than violating your own threshold that you established. It's just a huge, huge red flag to a reviewer. So state your level of significance, follow it in the reporting of your results, because this is a language element. The reason you've established a threshold is so when you go to your results, when you go to your discussion, and you tell the reader something like this was increased, this was decreased, they know what that means. You've defined the term increase or decrease based on your statistical significance threshold. All right, next in reports, so transparent reporting is a big key now. There's a huge trend toward reporting exact p-values. The ASA released a statement on p-values. P-values do not measure the probability that the studied hypothesis is true, or the probability that the data were produced by random chance alone, which I think would come as a surprise to a lot of scientists who would tell their students that this is what it does, and it does not do this. Always report exact p-values. Make sure that those are in there. You don't need to worry about that for tables and figures because you're simply marking what's a statistically significant difference. But if you're reporting actual mean differences within your result, just give an exact p-value. There's no reason not to. So keep in mind, p-values are useful only as decision-making tools. Their value is maximized by the context of the study and the addition of estimates, which we'll cover in the next slide. What the p-value tells you in inferential statistics, again, as the ASA is so clearly stated, it's not the probability that your experimental hypothesis is true, because a p-value is always telling you information based on a world where your null hypothesis is true. It's assuming that your null is true, and then what it's telling you is, if the null hypothesis is true, then this data that you collected, this is how likely it is. Okay, so keep that in mind. When you get a p-value less than 0.05, it's telling you if you ran this experiment 100 times, less than 5 of those instances would give you data this far away from your expected similarity between the variables. So that's what it's telling you, and that's why it's allowing you to make an inference. It's not telling you about whether your experimental hypothesis is true. It's telling you something about your data and how well your data fit the null hypothesis. If it tells you that your data fits the null hypothesis horribly, and in the scientific community, we decide horribly means 0.05 or 0.01 or less. If it fits the null hypothesis terribly, then we're saying, okay, it's probably acceptable to reject that null hypothesis and go with our alternative hypothesis, or one of our alternative hypotheses. So keep this in mind. If you're misstating these type of things, if this is bleeding into the way that you state your results, reviewers notice it. They know that you don't understand how p-values really work, and it's going to cause huge problems. They'll just say, I don't trust this, and that's it. They'll find a way to reject your paper. So a thing you can do to help, always report confidence intervals. Unlike a test for differences between means, the confidence interval provides a useful element of the sample means relative to the population mean. So your p-value doesn't tell you whether your result is more significant. However, reporting your confidence interval can tell you how important it is relative to the population mean. This extends the utility of the p-value by providing a bit of context for the differences between the mean. So always report confidence intervals. Again, there's no reason not to, and this is sort of a new norm that's being expected now. If you do it, you just simply check it off in the mind of the reviewer, and they say, okay, they seem like they know what they're doing. If you fail to do it, an error of omission, it may rate as a red flag. Reporting correlations, always give your R value, which can be contained within your R squared value. Remember that with correlations, your R value is the strength of your correlation, which again is context dependent. Depends on your field, depends on the variables that you're looking at. An R value for a piece of highly sensitive equipment should be 0.99, whereas an R value for some sort of sociological construct could be a lot weaker and still be quite strong, quote unquote. Your R squared value, your fraction of your variance explained by your independent variable, include this in your, there's regression equation in your graphs, in your tables, where possible. And finally, always try to provide a sum of least squares, again, particularly when you're using regression to model accuracy. Provide the sum of least squares in your reporting. P-value, keep in mind for correlations, it's of severely limited use. It's very easily to get a significant correlation, particularly if you have a reasonable sample size. Very weakly related variables will be statistically significant. Do not rely on statistical significance. If you're trying to tell a reviewer that your conclusion is valid because the correlation was significant, they are not going to be pleased with that explanation. So The concern is how much of the variance is being explained by the relationship. The p-value is simply the blunt test to say, does any sort of relationship exist from completely weak to exceptionally strong? Also, be wary of strong relationships where clustering occurs. Correlations generally work best when your data is distributed over the scale that you have set. If you have a scale set and your data points tend to cluster around the extremes, it's much easier for you to get a correlation. So just keep this in mind when you're interpreting the statistic and when you're making your conclusions. For your results, figures and tables, figures should be understandable independent of the main text. Again, this is a red flag for reviewers. If you do a descriptive title, this helps a lot. But this again goes back to the idea of not confusing the reviewer, not making your interpretations unclear. So make sure the figures and tables, all of these statistical concerns that they have, they should be able to address these statistical concerns, get answers to them within the figures and tables independently. Where possible, reference each table and figure in its entirety before moving to the next one. Readers prefer to not constantly go back and forth. Again, this idea, they want to align these elements of statistical analysis throughout the manuscript. Don't make them go back and forth. Panels should be used for comparison only, otherwise split. Again, a best practice for clarity. Careful truncating axes. This is a very basic thing that if you had any sort of basic statistics course, you've seen it, but if you truncate the axes, the reviewers are going to get upset. Make sure that it's okay to use the graph to visualize the data. That's the entire point of creating a graph, but don't use it to visualize insignificant differences. Don't make a difference appear significant when it's not statistically. So just be careful about how you represent data. Always maximize visibility. Here's a couple quick and easy things. Go back through your figures. You can do this on the manuscript you're working on right now. Increase font size, use boldface. If you have a color scheme, you can highlight. Don't use light text colors if it's a color figure, and don't use thin font types. For line or scatter plots with nearly overlapping groups conditions, try to balance individual line visibility with the ability to discern between lines where differences exist. In this regard, I think insets are great. I think every reviewer likes insets on figures when you're trying to parse out small nuances between groups, between time points. When you get to your limitations, this is a big thing. Introducing sample size as a limitation is super, super common. It's also a huge concern. The problem is when you say a simple statement like, oh, one of the limitations to the sample size wasn't very large, it raises questions in the reviewer's mind that don't need to be raised. If your sample size isn't large enough, you shouldn't be making your statistics are invalid. So that's a huge concern. It raises that in their mind. It also suggests that you misunderstand how sample size works. Sample size needs to be appropriate. It can be too small. It can also be too large. It's not just, oh, bigger sample sizes are better. That's not true at all. Additional studies, additional groups are helpful, but simply increasing your sample size doesn't make your conclusions more robust. In particular, it's important to keep in mind any variable, statistics are not perfect, particularly p-values. Any two variables, if you get a large enough sample size, you'll show that differences that really are due to chance, they're not real differences that exist between these variables. These differences will be significant if you get a large enough sample size. So constantly acting like sample size is this linear relationship between quality of your conclusions and sample size. It's inaccurate, and by stating this limitation so simply, you can raise a red flag with the reviewer. So be careful about that. If you're going to say that your sample size may be limited, run a power analysis and figure out how limited it is, and then report that. Another issue is confidence in the statistical analysis should always be established before the interpretation is conducted. Do not undermine reader confidence at the end of the manuscript without warning. Okay, so only address it if you know what you're talking about, particularly with regard to sample size. Finally, for your conclusions, match the study design and the statistical analysis. use of suggest, indicate, etc. is for inferences drawn from the results. It's not for the results themselves. Again, be cautious about statements of correlation. We don't have time to cover it, but you can look up the Bradford-Hill criteria, which can be useful for evaluating how well a correlation suggests causation. And then specify the exact conditions of the hypothesis when you're concluding. Finally, one reminder that I'd like to make, so this gets into the peer review type item. At this time, there's heightened accountability related to data manipulation, statistical analysis, all this stuff. Like I said, it's a lot different than it was a decade or two ago. Editors are more prone to seek consult on statistical issues. In the past, they're not very common. However, they're employed for a variety of reasons related to statistical issues. For you, you can preempt reviewer concerns by consulting a statistician a priori. Just put it in your methods, just like you might explain how you established clinical criteria with a small group of physicians in the field to make your subjective judgments. You can state that the experimental design and the analysis was conducted in collaboration with a certified statistician. This is always valuable. You can procure documentation, and this is always good because then you have that person to go back to, because sometimes an editor will ask you to go to a statistician to get your results verified. Okay, so I ran a little bit long, but I've got us into questions now. It looks like we have several already, so let me just bring them up and review them myself for a quick second, and then I will start working my way through them with you guys. Thank you for upvoting. This is a huge help. You guys have participated more than we have in the past, so this makes it easy for me to go through. Okay, first question here, let's get at. Okay, this relates to something I was just talking about, the sample size. Do all papers need to have a calculated sample size using a tool like I showed, like G3, or are there exceptions? I don't think generally it's required for every study. What I'm encouraging you to do is include it, because it's so simple, and most of the time your study comes out as adequately powered, and adding that there, something that most people don't bother, they just hope readers assume, because that's been the norm for so long. I think you give yourself a huge advantage. If I tend to be very statistically minded when I review a paper, and if I see something like that from someone, I instantly have this sense of trust in your statistics overall. And that's what you're looking to do. You're looking to signal this sort of statistical know-how to your reviewers. And so I would encourage you to report it, but the way you report it depends, because again, if you want to talk about limitations, you want to talk about sample size as a limitation, then you're going to be running the statistical test to show, based on the given sample size you have, what your power is. And then you're going to make a statement about how that power is adequate for the inferential statistics that you run, but could be improved now with larger sample sizes. On the flip side, I think the question you're getting at is, within your methods, you could actually report that as part of your study design, you selected the number of subjects per group based on an a priori power analysis, where you input a power you'd like to achieve, and then back calculated the appropriate sample size. If you can, it's super helpful. And you don't even have to do it explicitly. You don't have to figure out your sample size and then do your sample size based on that calculation. You can know what your expected sample size is and just confirm for yourself that you're close, and then report that in the methods. But long story short, you don't have to do it. I would encourage you to always try to include it where possible. Okay, next one. Are there any online tools to help you assess which statistical analysis you should perform on your results based on the research field? Okay, this is tricky. The short answer is no. It's very problematic. There's no, even simple experimental designs are a little bit complicated in terms of what stats are acceptable, it's best to go to a statistician, because what's probably going to happen, particularly if you come from an experimental lab, is you collect a lot of the same data. You change some of your experimental design, but it generally fits into a narrow category. And so a one-time consultation with a statistician will give you a great idea, an explanation for why you're doing certain tests. So I would encourage you to go seek out a statistician. The easiest way is just, most of you are at institutes, I believe. So you're at a university, go find a statistician at your university. It's generally not that difficult. You can get, there's simple statistical tools like the G-Power I put up, but there's really nothing that you can input your experimental design, which would be a long written description, and get an online tool to give you feedback on what tests you can run. And I really would hesitate to trust that. You're better off educating yourself, taking statistical courses that cover methods within your field, or going to a statistician and getting a consult and having them help you with it on a one-to-one basis. That's a much better approach. If we do find online resources, look for an article on the Learning Nexus that we have in the near future. I will try to, if we can find anything, make sure that gets posted up to the LetPub site. We can put together an article that may point you in the direction of tools for figuring out your statistical analysis. But the best thing to do is to learn it yourself, or to consult a professional, a statistician who can make sure that your methods align with your study design and the answers that you're trying to get. Okay, how to address the issue of variable follow-up rates in different groups in a retrospective cohort study statistically. This is an issue where I have to see the entire paper in order to give you an informed opinion. In particular, there's concern about how variable your follow-up rates are. If your follow-up rates are over a certain threshold, it's not necessarily something that you have to worry about. The concern is when you have one group with extremely low follow-up rates. So I'd have to look at, you have to look at the actual data you're getting. Again, this is something I would consult a statistician on for the specific data that you end up retrieving. You can't really, I don't believe that there's a statistical test to evaluate whether you've violated the conditions for making inferential conclusions based on variance in follow-up rates. I think it's more of a threshold. So again, consult a statistician on your actual data. If I don't have the data, I can't really make a judgment call on that. Here's another one. Again, the same thing applies. I have to see your data and your full experimental design, your methods to answer these type of specific statistical questions. But if I needed to analyze a lot of dependent variables at the same time among three groups, what statistical method should I use? How to define the relationship, for example, among the independents. An ANOVA can be used, which you list here. So you'd have a mixed ANOVA. You have multiple groups, multiple dependent variables. I don't think it's ideal. You probably want a MANOVA, and the ANOVA is really more pertinent for repeated measures among those groups, not multiple dependent variables. So you probably want a MANOVA. However, the question is, are some of the dependents that you have really covariates? So some of the dependents are covariates, then you're looking at an ANCOVA instead of a MANOVA. And more importantly, once you've established which of those, you have to figure out what your post hoc test is going to be. So you're going to need an appropriate post hoc test. And again, I'd have to actually look at your data to suggest that. But you can start with MANOVA, but you really need to consider if you have one of those dependents as a covariate and whether you would need an ANCOVA. So again, consult a statistician with the actual data you've collected. I have a question here about Kruskal-Wallis because I recommended, or I didn't recommend, but I placed some other tests up there. Kruskal-Wallis test is fine. Like I said, the reviewer's probably not even concerned about your specific test there. They just want to look that you're aware and that you know that you're supposed to be reporting that type of thing so that you know you made the correction. But yeah, Kruskal-Wallis test is a fine test. I would select it. I showed the pros and cons of each of those tests up there. So select based on those pros and cons, but that's simply one I didn't add into that list, but the list isn't complete. So yes, you could very easily add that to the list. Is the description of a hypothesis given in terms of constructs or variables? I prefer for it to be in terms of variables. I think, again, it makes it easier to align with the results. So I suggest that you put in variables. It's not a hard and fast rule. You can get away with hypotheses that are less of a statistical statement. But again, if you're having problems with your papers because of statistical review by the journal editor, by the peer reviewer, I think it's better to become more explicit, and I would use variable terms for your hypothesis statement. There's a question about why large sample size can be a problem. Again, just to revisit, well, large sample size is not necessarily a problem. It's just if you have an excessively large sample size, it can be easy to get a statistically significant difference, but the difference is biologically insignificant because you're detecting a difference between the means, but you have such high sensitivity because of how large your sample size is that you're either finding, technically if it gets large enough, you can always find a difference that doesn't actually exist. Even if it does exist and you've just identified a very small difference, it can be so small that it's functionally irrelevant, even though it's statistically significant. So don't worry about it too much being a problem. It's just when you state it as a limitation and imply that you don't understand that you seem to think sample size is a linear relationship with quality, it can set off red flags for viewers. So just be aware of that. So a question about median, because we talked about measures of central tendency. The median is typically used to report data when it's not normally distributed. So if you violate a test of normality, you can go with median reporting rather than mean reporting, because then any sort of skewness will be less impacted if you're utilizing median. So that's typically when we use it. In that point, you want to use interquartile range. That's the best way to report your dispersion around the median. So yes, I would use the interquartile range for a median, and again, the median being used when you have non-normal data. Another question, if you have a small qualitative study with 1 or 2 samples, what measure of central tendency will be appropriate? Really no measure of central tendency in that instance. I don't think you can be using inferential statistics if you have very small sample sizes like that. You'll simply have descriptive statistics for your findings. This is often the case in case reports, that type of thing. So it's not always necessary because, again, not all of statistics is hypothesis testing. It's just the major component. So in this instance, it doesn't necessarily apply. and you're not going to have a problem with a reviewer in that regard. I have this question. It's a little bit vague. Maybe I can touch on a couple items. Can you provide some insights about common method bias? There's a huge amount of method bias, and you'd have to go method by method. As I pointed out, we'll go through some of the common ones. So a big problem is with the p-values. I already mentioned comparing p-values. A p-value is not the strength of a difference, right? So a p-value is giving you confidence that the data you collected does not support the null hypothesis. And so if you can't compare two results on the strength of their p-values. I see that quite often and it doesn't make sense. So avoid that. Correlations, I think, are the bigger one for actual method bias. The problem with correlation, again, as I pointed out, is clustering. So if you have clustering around the poles and you're not distributed evenly for your observations over the scale, it's simply not productive to report that it's a significant relationship unless the relationship is strong. Correlation analysis is very susceptible to the clustering effect. So just keep that in mind. When it is appropriate to use the Mann-Whitney U-test and more in general, the other non-parametric tests. So yeah, the biggest split in data is parametric versus non-parametric. That informs the testing that you're going to be performing. So that's all. That's it. Any non-parametric test is applied only to non-parametric data. So that's something that needs to be identified early on. That's something you should generally have an awareness in your lab if the data you collect fits one of those categories. However, I've run into it before where data that I've collected has been non-parametric that I realized after the fact was going to be problematic, and so we had to change at that time. Again, in that situation, I actually consulted a statistician. So if you're unsure, go to a statistician. But yeah, generally Mann-Whitney U and any other non-parametric test is only suitable for non-parametric data, at least as a norm in the fields. What is your opinion about the Cohen article, "The Earth is Round, P less than 0.05? I haven't seen the article, so I can't give an informed opinion on it, but I will be looking it up immediately after this. So thanks for volunteering it. I encourage everybody to actually go look at this then. Even if I disagree with it, I'm sure it's quite helpful. Any statistical content that gets posted nowadays and like editorial articles and that type of thing, it is usually very interesting discussion. So I encourage everybody, look up the Cohen article, "The Earth is Round, P less than 0.05. Could be a nice follow-up to this webinar. How do I choose among multiple comparison tests? Again, I have to see the data, but again, reviewers really don't care too much about your correction, Bonferroni, Sidak, Tukey, this type of thing. I placed it up there so you could see it. Let me actually see if I can go back for you. Yeah, so you can see here, Bonferroni is a more conservative one. When you have a large number of hypotheses or correlated test statistics. Sidak is higher power, so you're more likely to detect a significant difference, but less corrective for negatively dependent tests. And these are actually just small summaries. There's other nuances to these. And then Tukey, for example, Tukey is one that's hard and fast. You can only use it for pairwise comparisons. You can't apply a Tukey. But again, your software will typically limit you. Your software knows these type of things and won't let you select it as an option. Otherwise, it's just a subjective opinion on what you think is the most appropriate. But again, just report the one you want to use or that you did use. That's what a reviewer is looking for, that you made a correction, that you knew to select a correction. So it shouldn't be a problem. Also, I have had reviewers that ask me to go back and try it with, what'll happen is they'll ask you to go back, do a different post hoc test, a different correction. You go back and it's the same. It doesn't change anything. So it's actually, you can run them. You can run them all together if you want to see if there's a problem. but don't do that to select the one you want to use. Don't run them all together and find one that gives you significance and use that. It's a recipe for disaster. Pick the one you think is the best to use it. You can run the other ones to see the results that they give you, so you'll know if the reviewers then come to you and want you to try something different. Okay, how many more do I have? I don't think we'll get through all these, but I'm gonna hustle through another quick couple. I'm gonna try to pick two more really good ones that we have here. It doesn't mean your questions aren't good, ones that I think are helpful to everyone. Okay, here's a good one that revisits the topic we were discussing. If the peak value becomes 0.05 at a significance level of 5%, how to report it as a significant, non-significant, or what. So this is where less than or equal to comes in. I think generally people expect reporting less than 0.05 for threshold or less than 0.01, not less than or equal to. So if it's 0.05, it's technically not a significant value. It is still a norm that you can report a trend, so it's trending towards significance. And again, if you report an exact p-value, there's latitude. So if you say that the effect wasn't significant, or the effect didn't exist is more accurate. If you say there's no effect, p-value is let's say 0.51, 0.051, something like that, very, very close. That's why you report an exact p-value. Then you leave it up to the reader to make an interpretation. You can't conclude anything strong based off of that, but they understand what your p-value came back as, and they may still view your work as impactful, even if it's a non-significant result, because they know you could do the study again and you could find something significant. So report it based on your thresholds. Be very strict to yourself about that, because reviewers get mad when they think you're trying to get away with something. So report it very explicitly, but again, this is where reporting exact p-values comes into play. If you report the exact p-value, it can still be interesting to the reader when you're right at the edge of that threshold. I'll do a quick answer to this one. Is having no control variables in a model negative? I'd have to look at your entire study design and everything. You don't necessarily need controls all the time. Depends on what your results are. Also, sometimes you can use controls from previous experiments. You can bring back a control group as long as there's no effects of the passage of time. The animals, subjects that you get back for it, as long as there's continuity. So it depends is the answer. Sometimes you don't need controls. Sometimes you can reuse controls, but a control always helps. So if you have it, report it. If you have the ability to do it and it's not going to be exceptionally difficult for your lab, include them in your planning. Always plan to have controls if possible. Here's a question on causation. For the expression A predicts B, does it mean A is the cause of B, or does it simply means there's an association between A and B? This is the danger of language with correlations that I was pointing out. If you say A predicts B, it's generally okay, because when there's a relationship between two variables, it can predict it without being causative, right? Does that make sense? So like, for example, marketing, or actually let's use this. A common correlation example that we see when we're trying to harp on correlation does not equal causation for people is the sale of ice cream cones and drowning deaths in the summer, right? They're not related. They have a common covariate that causes both of them. That doesn't mean they're not still predictive of each other, because more people out eating ice cream cones at the beach, again, along with those covariates, means more people swimming. So when someone says that A predicts B, they're saying that there's an association or relationship between them, and it makes sense because there's an R squared value, right? If you have a very high R squared value, let's say 0.5, that means 50% of the variance is explained. 50% of the variance in B is explained by A. That does mean that A predicts B. It doesn't necessarily mean A causes B. So that's acceptable language to use, but make sure you're thinking about that when you report it yourself. Okay, I don't have time for any others, unfortunately. However, we will take into consideration any remaining questions and some of the questions that I was able to answer. And perhaps we can include them in future educational articles that we have. Also, when we get lots of Q&A like this, quite often we do a follow-up webinar session where we can open it up for general questions related to the topic. In this case, the statistical approach to your manuscript. So look for that in the future. We may, in the coming months, do an open forum on statistics where we can bring in a guest, perhaps some people experienced in different areas of statistics, and we can get some questions answered, your detailed questions in more of an open forum. So I do want to thank you for tuning in. One thing I do want to note, I noticed a question earlier. These are all recorded, so this is on demand available for you. After you close out, there will be an invite. You'll be able to get the link. You can share this with whoever you want. If you are sharing it, please just make sure that you post where it's coming from, obviously. If you're resharing at a website or anything, make sure that you're putting us in there. But otherwise, yes, you are free to revisit this topic. And again, be on the lookout for more statistics related webinars at a future date. So I want to thank you all for tuning in, particularly as many of you are practicing social distancing. I hope this was a nice break for you to get some face time with me and be able to discuss what I think is a very pertinent issue in scientific research, more importantly in scientific publishing. So I hope these issues that we've covered help you in success with your future projects. Keep in mind that if this is still a concern, you can always come to us. We do have our scientific editing service. We try to address a lot of these concerns that reviewers are on the lookout for related to your study designs, your hypotheses, etc. So if you want a professional in your field who can review this type of content for you, do visit letpub.com. Think about utilizing our services for one of your next manuscripts. Alrighty, that's it for me. Be on the lookout for an announcement for our next webinar in the coming weeks. Thanks for joining me, everybody. Take care.